in infrared and terahertz region. This is my presentation outline. Here is some technical items I will use in my presentation. In introduction, I will talk about water and its isotopes, and as well as isotope effects. In methodology, I will introduce terahertz and also ATR terahertz device. Also, I will introduce mid-infrared and near-infrared device I used in my experiment. Heavy water is water which highly enriched in hydrogen's isotope deuterium. Heavy water is 11 denser than water. We can see this table. This table is the properties of water and heavy water. This table shows, besides the atom mass, their physical and chemical properties are similar. But water and heavy water, biological properties are different because the different atom mass, the incremental strength of the deuterium oxygen bond increased. Semi-heavy water is a water exists whenever there is water mixture with distilled water and heavy water. When in the aqueous solution, there will be a dynamic equilibrium of the composition of semi-heavy water, which is like this. These three parts, semi-heavy water, distilled water, and heavy water, they will transform into each other to keep the balance of the concentrate. What is the structure of water? This is a question listed in Science 125 anniversary issues asked by many researchers. Water is the most important material in agriculture industry and living organisms. Still, many fundamental questions on liquid water are unexplained, such as free water and combined water, and also how many free oxygen and hydrogen-oxygen bond will connected with its neighbors, and such as what is the effect of temperature on water structures. Because water has a very strong absorbance in terahertz region, so the characters of hydrogen bond in terahertz region are still unknown. So, the objective of my research is first investigate hydrogen bond characters and temperature effects in terahertz region by comparing distilled water and heavy water. And then I will investigate hydrogen-oxygen bond, oxygen deuterium bond, and semi-heavy water bond, as well as free bond and combined bond characters by comparing near-infrared, mid-infrared, and terahertz spectra. What is terahertz? Terahertz is a microwave lies between electronic waves and optical lights. This area contains a lot of information about intermolecular vibration, such as hydrogen bond and van der Waals. Former researchers using our device has already shown first, terahertz contain distinct low-frequency information compared with infrared spectrometer on structures. Terahertz is sensitive for intermolecular reaction and vibration compared with X-ray diffraction and nuclear magnetic resonance. Unique vibration signatures can be used to identify. This is the device I used in my experiment, terahertz device. This is the silicon and silicon's parameter. This is the sample unit. We add samples in the sample unit. Here is the principle of the device. First, when light coming through the interface, some parts of light will change its orientation and like this. This is called evanescent wave. Evanescent wave contains a lot of samples information. we can calculate the penetrate depth by this equation. This is another sample unit I used in my experiment. This unit contains the heating system and the temperature sensor. The heating temperature scale is from room temperature to 80 degrees centigrade. When we heat the samples, we first heat the silicon like this, and then by heat transform, we heat the sample. This is a mid-infrared device I used in the experiment. Made by maker is Brooker. The region is from 375 per centimeter to 7,500 per centimeter. This is the ATR unit. We add the sample here in the diamond. This is a near-infrared device I used in the experiment. The region is from UV to near-infrared from 190 nanometer to 2,700 nanometer. This is the inside of the sample unit. We put, when we measure samples, we put reference and samples in the two light paths. This is optical cell made by crystal. This is a measurement picture. Okay, now I will do a very quick previous result overview. This is a result of terahertz of heavy water and mixed water and distilled water measured in terahertz region. We can see from this figure, first the curve has some shift, value shift from heavy water to from distilled water to heavy water. And also, according to a reference, water should have a vibration stretching band at 5 terahertz. My data just match the reference very well. And then I will show another previous result. This is the temperature dependence of water, and this is the temperature dependence experiment of heavy water. These two figure, this two figure has a trend of the from low temperature to high temperature. The value also shift. So we can get the conclusion. First, heavy water, distilled water, and semi-heavy water have different absorption spectra at the same temperature. Second is redshift from distilled water to heavy water, just coincide with the reference paper from a shift to the low wave number. It means low energy. This is because water is a non-linear 3-atom molecules. It has 3 vibration models. First is symmetric vibration, and then bending vibration, and asymmetric stretching vibration. During change from water to heavy water, the symmetric stretching vibration and asymmetric stretching vibration, their overlapping stretching band has shift because the incremental of the atom mass. Oh, sorry. This is a mid-infrared result of my experiment. We can see the blue line is heavy water, the red line is mixed water, volume half-half, and the green line is distilled water. From this figure, we can see here at the 2005 per centimeter, heavy water has a distinct peak from waters. I will show another literature. This figure shows a single beam spectra of water and heavy water. This reference paper also shows in water has a very strong absorption band between 3,007 per centimeter to 2,700 per centimeter, and also 1,007 per centimeter to 500 per centimeter. Heavy water has a distinguished different absorption band, didn't overlap by water, centered at 2,500 per centimeter. And also we can see from this figure, here has a new peak for the mixed water. In order to confirm whether it is I consume it is because HOD band caused this band. So in order to confirm whether it is HOD bound or not, I conduct again the experiment. In this experiment, I use two different concentrate samples, and we can see from this figure, almost the shape is remains the same. So it means the experiment repeatability is good. And we can see for the mixed water, two different mixed water, this band remains the same. So I think I can say this band is the HOD band, and I guess it can used for quantitative analysis. Here has another reference. In this paper, the author using this 6,000 per centimeter as the quantitative analysis index. So in my experiment, I hope I can use the 3,500 per centimeter as the HOD band quantitative analysis index. Here is the conclusion of my experiment. First, attenuated terahertz reflection terahertz spectroscopy can detect hydrogen bonds vibration in aqueous solution. And second is hydrogen-oxygen band, deuterium-oxygen band have similar stretching vibration band at around 5 terahertz, but the temperature dependence are little different. The third one is 3,500 per centimeter might be used for HOD bound quantitative analysis. This is my future work. First, I will conduct heavy water concentrate dependence experiment again in order to make sure whether this band can be used for quantitative analysis or not. The second one is I'd like to repeat near-infrared experiment. Today I didn't show any result of near-infrared experiment because I conducted twice. The first time I used air as reference, but the result is very strange. All the values of absorbance are negative. And second, Suzuki-san helped me measure again. In the second experiment, we used two different length path cells, and both using water as a reference and sample. In this time, we get the positive value, but the results are still a little strange, but improved. So later I will repeat this experiment again. And the third is analyze the milk data I obtained for the last 2 months. And that's all. Thanks for your listening.
Always confused with wave number. If you show wave number graph. than per centimeter.
Mm.
Then sometimes the opposite, this is the smaller number.
Oh, yes.
Then, but this time, for example, before this, maybe, yeah, this is
Hmm?
up, something. This way. And this one and one more before. This is, yeah, 307 and 3,000. Then comparing this one.
Which one?
Yeah,
This one?
this one should be maybe this one.
Oh.
Yeah, something, is it same tendency or some completely different? It is correct? I was confused.
Maybe I made a little mistake
Mistake?
in making the graph because the graph Excel is not work. I don't know why, so maybe I made it a little mistake. But I think this should be the correct one.
This is correct.
Yes, yes, and that one may be a little strange, not so correct. But sometimes in calculus region, we make graph in a reverse order, and in maybe it's
Yeah, that's fine. We try to know which region is mid-infrared and far infrared.
Which region?
For example, for this one, 11.
11.
11.
Oh.
Which region is mid-infrared?
Which region is
Yeah.
medium?
Around here, 10.
3. Where is the? Which region? From.
375.
This is mid-infrared. Oh, maybe 7. From 375 centimeter to 7,000.
From here to?
Not. This is not the whole range.
I know. Then far infrared and
Okay.
middle infrared is included in this?
No.
No?
Near infrared is from nanometer to 2,000 nanometer.
Yeah, I know.
Nanometer.
So, then
Nanometer needs to make a calculation.
Okay. I'll do that by myself. Okay.
Using this one, just make
If you
this
know,
one.
show.
I know, but
You don't, okay. Fine. That's a small.
Then our device has the whole range, just the continuously whole range. I already calculated, but I forgot the exact number. Sorry.
Yeah, anyway, any other suggestion?
I think please show me number 9.
Oh, yeah, sorry.
Number 10.
This one?
Yeah.
Which one?
You said the spectrum change depends on the temperature and
Oh,
the
here.
concentration of heavy water. Why the spectrum shifts?
This one?
Why?
Oh, this one. Why shifts? Because water has 3 types vibration: symmetric, symmetric and asymmetric. Symmetric and asymmetric and bending. I read some reference. It is said the symmetric and asymmetric stretching band will overlap. And because heavy water atom mass increased about 11%. So the band strength increasing. It is caused the overlapping band shift. Can you understand? Because change of mass will lead to change of the stretching of the band. Stretching of the band will change the absorption.
Okay, any other question?
Wisman, can you show me your slide number 2 and then slide number 3? Okay, on your objective. That is slide number 4. Okay, I'm trying to figure out exactly what is the problem you like to solve, your experiment. What do you want to accomplish?
Just conduct some research on structure of water.
You conduct some research. What is it you are meaning by some? What does some mean? What specific problem you want to solve?
Because I think the structure of water in telahertz region is blank. So we want to fill out the blank area. Not so, how to say, not so meaningful in daily life or in some certain issues or something. Just some fundamental experiment.
Okay. That's okay. So the question right now is that the study of the water structure have been extensive by chemists for many, many years.
Yes.
So based on your research right now, what is the understanding right now about water structure, and what kind of blank you want to fill in by terahertz? What's not known?
Such as water has very strong absorbance in telahertz region. So before, very few or no researchers has conducted by telahertz. They just conduct mainly on mid-infrared, near-infrared, and mainly no terahertz region. So we obtained our spectrum of water in terahertz region, and because we don't know right or wrong, so we compare. We repeat again and again until get a very good repeatability, and we can say this basic data can used for any other research. Because water also in industry, if you want using some terahertz monitor to monitor some industry process, you must know the basic spectrum or basic characters of water in terahertz region.
Based on your result right now, what is the some of the conclusion you can come up?
Basic, I think it is isotope indeed has some effect for water in the terahertz region, and also I think when terahertz, our device can detect the hydrogen bond vibration, different types of hydrogen bond vibration in this area. Because I think I conduct many times experiment, and every time the mixed water, heavy water, and distilled water, they have different absorption data. Also, their temperature dependence are different. Maybe I need more data to get a conclude. And so now I want to try to compare with mid-infrared and near-infrared region, because in our laboratory we have the whole range of the spectrum. So maybe previous research only did mid-infrared or near-infrared, but they didn't compare at the same time several different paths spectrum. So we have the advantage.
Okay, it's time up. So if you have any question or suggestion, please tell us. Yeah, thank you very much.